The universe is a place of infinite wonders, filled with mysteries that have puzzled humanity for centuries. But out of all the cosmic phenomena, one stands out as both terrifying and fascinating: the black hole. Hey there, space enthusiasts! In today's adventure, we're diving deep into the enigma of black holes. We'll uncover what happens inside these cosmic beasts and brace yourself. What would happen if you fell into one? So buckle up, because this is going to be a wild ride across the universe. To understand black holes, we first need to talk about their origins. Imagine a star much larger than our sun, massive and burning with intense energy. As it ages, this star burns through its fuel, leading to a dramatic end. When it can no longer sustain nuclear fusion, it explodes in a supernova, and what's left behind is the core, a point of unimaginable density. If this core is heavy enough, it collapses under its own gravity, forming what we call a black hole. Now, what makes a black hole so unique? The key feature is the event horizon, an invisible boundary around the black hole. Once something crosses this boundary, there's no turning back. Not even light can escape. This is why black holes appear, well, black. Think of gravity as a stretched rubber sheet. When you place a heavy ball on it, the sheet bends. If the ball is heavy enough, it makes a deep well. A black hole is like making such a deep well in space-time that nothing can climb out of it. Black holes come in different sizes. There are stellar mass black holes, which are formed from collapsing stars, supermassive black holes, which reside at the centers of galaxies and are millions to billions of times more massive than our sun, and theoretical miniature black holes, which might have formed in the early universe. Each type has its own unique properties and mysteries. Fun fact, did you know that the supermassive black hole at the center of our galaxy, Sagittarius A*, has a mass equivalent to about 4 million suns? And yet it's all packed into a space smaller than our solar system. So, what happens if you get too close to a black hole? Imagine you're in a spaceship, bravely venturing near the event horizon. As you get closer, something strange starts to happen. Gravity is much stronger at your feet than at your head, and this difference in gravity stretches you out like a piece of spaghetti. Scientists call this process spaghettification. You'd be stretched thinner and thinner until, well, let's just say it wouldn't be a pleasant experience. But what's really mind-boggling is what happens after you pass the event horizon. Once inside the event horizon, all known laws of physics start to break down. At the very center of the black hole lies the singularity, a point of infinite density where gravity is so strong that space-time itself becomes infinitely curved. Here, the concepts of time and space as we know them cease to exist. This is where things get really tricky. Our best theories, Einstein's general relativity and quantum mechanics, struggle to explain what happens inside a singularity. General relativity tells us that gravity is so intense that it warps space and time, but quantum mechanics suggests that there should be some kind of quantum foam at such tiny scales, preventing a true singularity from forming. The truth is, we don't have a complete theory that can describe what's really happening in there. Some scientists even speculate that black holes could be gateways to other parts of the universe, or even to entirely different universes. These are purely theoretical ideas, but they spark the imagination. Could black holes be cosmic tunnels or wormholes that connect different regions of space-time? Studying black holes is like looking into the deepest, most mysterious part of the universe. We're pushing the boundaries of our understanding of physics, and one day, we might discover something revolutionary, like a new form of matter or even a deeper understanding of the fabric of reality itself. Now, let's get to the big question. What if you were to fall into a black hole? Well, it depends on the size of the black hole. Let's explore a few scenarios. Scenario 1. Falling into a stellar mass black hole. This is the most common type, formed from the remnants of a massive star. As you get closer, the tidal forces would increase rapidly, stretching you out into a long, thin shape. Spaghettification strikes again. Before you even reach the event horizon, you'd be torn apart by these intense gravitational forces. So, in a stellar mass black hole, your journey would end before you even get to the good part. Scenario 2. Falling into a supermassive black hole. These giants, like the one at the center of our galaxy, are much larger and have a weaker tidal force at the event horizon. You could actually cross the event horizon without being immediately spaghettified. But don't get too comfortable. As you cross the event horizon, time would start to slow down dramatically. To an outside observer, it would look like you're frozen in time right at the edge of the black hole. But for you, time would seem to pass normally as you continue to fall inward. As you fall deeper into the black hole, you'd experience some truly bizarre effects. The gravitational forces would eventually overwhelm you, leading to your inevitable demise at the singularity. But what's fascinating is that from your perspective, you might feel like you're falling forever, Some theories even suggest that you might reach the singularity in finite time, or possibly never, as the concepts of space and time become warped beyond recognition. Scenario 3. The wormhole hypothesis. Imagine that instead of being crushed or stretched, falling into a black hole could actually take you somewhere else. Some physicists have proposed that black holes could be connected to white holes, forming a wormhole that links two distant points in space, or even different universes. This idea is purely speculative, but it's one of the most exciting possibilities out there. It's like a cosmic roller coaster ride through space and time, where the final destination is a complete mystery. So why should we care about black holes? After all, they're far away, and it's unlikely we'll ever encounter one in our lifetimes. But black holes are more than just cosmic curiosities. They play a crucial role in shaping the universe. The supermassive black holes at the centers of galaxies, like Sagittarius A and our Milky Way, are essential for the formation and evolution of galaxies. Their immense gravitational pull influences the movement of stars, the formation of planets, and even the distribution of dark matter. Without them, our galaxy and life as we know it might not exist. By studying black holes, we're pushing the boundaries of our understanding of the universe. The first ever image of a black hole, captured by the Event Horizon Telescope in 2019, was a monumental achievement. And it's just the beginning. We're learning more about how black holes interact with their surroundings, how they grow, and what they can tell us about the fundamental laws of physics. Black holes are some of the most mysterious and powerful objects in the universe. They challenge our understanding of reality and inspire us to explore the unknown. While falling into one might not be the best idea, learning about them can give us a deeper appreciation for the cosmos and our place in it. Thanks for joining us on this cosmic journey. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-bending explorations of the universe. And let us know in the comments, what space mysteries would you like us to explore next? Until next time, keep looking up and stay curious.